Have you ever wondered whether we are completely alone in the vast cosmos or not? Both possibilities carry profound and terrifying implications. If Earth is the sole cradle of intelligent life, then the responsibility for the preservation and evolution of intelligence in the universe rests entirely on our shoulders. On the other hand, if we are not alone, it raises unsettling questions about the intentions and capabilities of other civilizations that inhabit the vastness of space. The possibility that we are alone is not only solemn but also frightening. In a universe filled with stars and planets, the idea that only Earth developed intelligent life places an enormous responsibility on us. Can you imagine the weight of being the only advanced civilization in an empty cosmos? The urgency to maintain and expand our knowledge and technology becomes even more pressing. Conversely, the perspective that we are not alone leads to a series of questions and mysteries. What are the intentions of other civilizations? Are they technologically advanced or even more primitive than us? The question becomes even more complex when we consider the vast number of planets that could harbor life, raising the possibility of encounters with beings whose intentions and capabilities we can barely imagine. The Fermi paradox is one of the greatest enigmas in astrobiology and physics. Given the immense number of stars and planets in the universe, the question arises, why have we not yet detected signs of intelligent civilizations? With billions of stars in our galaxy and a potentially infinite number of habitable planets, the lack of contact with other forms of life raises intriguing and even unsettling questions. The paradox is a fascinating and challenging reflection on the apparent contradiction between the high probability of extraterrestrial life and the lack of observable evidence. Even with increasingly advanced technologies and ongoing space explorations, the absence of clear signals or contact with other civilizations remains a profound mystery. This enigma forces us to reconsider our understanding of life and intelligence in the cosmos. This lack of answers leads us to deep contemplation about our position in the universe. If there are so many possibilities for life, why have we found none? The paradox challenges us to explore new theories and possibilities, driving the quest for knowledge and discoveries that could finally resolve this question and change our perspective on the universe and our place in it. The Milky Way, our galaxy, is a vast ocean of stars, estimated to contain between 100 billion and 400 billion of them. Among these stars, about 5% to 20% are similar to the Sun, giving us an idea of the colossal number of star systems that could harbor Earth-like planets. Based on these data, it is estimated that there are approximately 5 billion Sun-like stars, offering enormous potential for the existence of habitable worlds. Considering that 22% of these systems may have planets in habitable zones, we have an estimate of 1.1 billion planets that could have conditions similar to Earth. This vast number of potentially habitable planets makes us reflect on the chances of extraterrestrial life. With so many places where life could emerge, the question of the Fermi paradox becomes even more intriguing. If the number of potentially habitable planets is so large, why have we not yet detected signs of intelligent life? The vastness of the universe and the impressive number of stars and planets amplify the mystery, leading us to question whether we are observing in the right way or if there are unknown factors we are ignoring. If 1% of habitable planets developed life, and 1% of those planets with life evolved to form intelligent civilizations, we would have about 100,000 intelligent civilizations just in our galaxy. This number is surprising, considering the number of planets that could harbor life and intelligence. However, the lack of concrete evidence of such civilizations leads us to deeply reflect on the Fermi paradox. The question arises, if there are so many intelligent civilizations, why have we not yet detected clear signs of their existence? We are facing a cosmic mystery where the lack of proof contradicts the high probability of intelligent life. Perhaps there is something fundamentally wrong with our assumptions about how and where to look for signs of extraterrestrial life. This discrepancy between expectation and reality fuels the enigma of the Fermi paradox, challenging our theories and search methods. Are we missing a crucial piece of this puzzle, or is there a more complex reason behind our inability to find advanced civilizations? The Great Filter theory proposes that there is a filter in the evolutionary process that makes intelligent life extremely rare. This filter can be located in the past, such as the emergence of life, or in the future, represented by challenges that civilizations face to survive in the long term. If intelligent life is as rare as the theory suggests, this could explain why we have not yet found signs of other advanced civilizations. If the filter is in the past, it means that the emergence of life, and especially intelligent life, is an extremely rare and difficult event. This would imply that life, as common as it may be, has a very small probability of evolving into advanced intelligence, making our existence even more precious and unique. On the other hand, if the filter is in the future, it represents a challenge that civilizations face as they develop technologically. Technological disasters, climate change, or even self-destruction could be barriers that prevent most civilizations from surviving in the long term, explaining why we have not yet found signs of intelligent life in our universe. The zoo hypothesis suggests that advanced civilizations choose not to interfere or communicate with primitive civilizations like ours and observe us from afar, as if we were in a zoo. According to this theory, these civilizations would have a policy of non-intervention, respecting a type of non-contact protocol with societies that have not yet reached an advanced level of development. To explain this hypothesis better, imagine that you are in a park, observing a dog. Now, imagine you are a math teacher trying to teach complex concepts to this dog. Of course, no matter how hard you try, the dog lacks the capacity to understand calculus, algebra, or geometry. You might try using treats and toys to get it to respond to your instructions, but the dog will never reach the level of understanding needed to truly learn math. The zoo hypothesis works similarly. Advanced civilizations would be like you trying to teach math to a dog. They might be observing our civilization, but just as the dog cannot grasp math, we, as more primitive civilizations, might not have the capacity to comprehend or interact with these advanced beings. Thus, they observe us from afar without interfering, respecting our current stage of development, just as you would respect the dog's limitations. If this hypothesis is true, then we are under the observation of highly advanced civilizations that prefer to keep a safe distance. This would raise the intriguing question of how our society would be if we knew we were being monitored but without direct contact. The idea of being in a cosmic zoo adds a layer of mystery and responsibility to how we interact and develop as a species. Additionally, the zoo hypothesis implies that the evolution of advanced civilizations may follow a path similar to an observation and non-interference policy. This leads us to reflect on how our own approach to other forms of life, if found, could be shaped by ethical principles and non-intervention, much like we imagine other civilizations doing. The evolution of intelligent civilizations is not a linear path and faces complex obstacles. Think of an advanced civilization as a thriving tree. Each branch represents a technological advance or an evolutionary leap, but for the tree to grow, it must overcome challenges like storms and diseases. These obstacles can include natural disasters, devastating wars, or extreme climate changes. Just as a tree needs a stable environment to thrive, a civilization needs favorable conditions to continue evolving. Civilizations may face internal challenges that prevent them from reaching a more advanced stage of development, resulting in collapses or stagnations. These challenges are like the weather conditions that can prune branches and limit the tree's growth. Therefore, the evolution of intelligent civilizations is as vulnerable as nature, subject to unpredictable forces. Survival and advancement depend on overcoming these obstacles, which could explain why some civilizations seem to stagnate or disappear before reaching a truly advanced technological level. And, in considering these challenges, what could we learn about our own evolutionary trajectory? To understand the Fermi paradox, it is crucial to explore possible solutions that could explain why we have not yet detected signs of intelligent life in the universe. Moreover, there is the possibility that intelligent life could exist in forms we do not understand, such as entities based on energy or extreme conditions. This concept is like searching for a form of life in a habitat we barely know. What we are looking for may not match what really exists. Each of these solutions opens new questions and perspectives about the universe, leaving us more curious about what might be hidden beyond our reach. The dark forest theory proposes a chilling view of the universe. Imagine a vast and dark forest where each civilization is like a stealthy hunter, avoiding making noise to avoid detection by invisible predators. In this scenario, darkness and silence are survival strategies, where each civilization hides, fearing that revealing its existence might attract dangerous threats. This theory suggests that, just as animals in the jungle avoid predators, advanced civilizations avoid revealing themselves to avoid attracting the attention of potential hostile civilizations. It is a universe where safety is based on invisibility and caution, and any sign of intelligent life could be an invitation to destruction. Finally, this theory implies that the universal silence is not just an absence of communication but an active strategy to avoid confrontations. If all civilizations adopt this behavior, the universe becomes a place of apparent desolation, full of hidden life under a veil of darkness. This makes us reflect on the real reasons for cosmic silence and what is truly hidden from our view. In a universe full of possibilities, the idea of advanced technologies is fascinating. Imagine a civilization that developed technologies so sophisticated that they became almost invisible to us. These technologies could integrate into the environment so perfectly that they blend with nature, making any detection extremely difficult. With these technologies, it would be possible for alien civilizations to carry out intergalactic travels, manipulate matter, or even alter realities, but all in a way that we cannot yet imagine. The mystery about what these civilizations are capable of doing becomes even deeper, raising the question of how we could detect signs of intelligent life in such a technologically advanced universe. Looking at the vastness of the universe, where the possibilities of life are almost infinite, when we think of extraterrestrial life, we often imagine it as being similar to us, with forms and characteristics we can recognize. However, the truth is that alien life might be very different from what our minds can conceive. Alternative forms of life could exist in radically different conditions from those on Earth, such as in environments with extreme temperatures or unusual atmospheres. These entities could live in parallel dimensions or use forms of communication that defy our current understanding. As we explore the cosmos, it is essential to keep an open mind to the infinite possibilities of how life might manifest. After all, the universe may be full of beings and forms of existence just waiting to be discovered. By exploring the complex layers of the Fermi paradox, we reach a deeper understanding of our own place in the cosmic vastness. Each theory, from the Great Filter to the Dark Forest theory, offers us a new perspective on intelligent life and its possible reasons for the universal silence. While the enigma continues to challenge us, it also inspires us to look at the sky with renewed curiosity and hope. If you want to delve even deeper into these mysteries and explore other fascinating topics about the universe, subscribe to our channel and activate notifications. The adventure is just beginning, and the answers may be more surprising than you imagine. See you in the next video.